Well, hello, oceanography students, period two. This week you guys should have completed your midterm and any assignment that you did not complete prior to the midterm. I open them back up so you can edit and change any answers or resubmit anything that you're missing. Um, Going forward, you need to complete the do nows each morning by 10 a.m. And today we're working on ocean currents and global winds. So you do now for this morning is about the Gulf Stream. The Gulf Stream is a strong ocean current, brings warm water from the Gulf of Mexico into the Atlantic Ocean. It extends all the way up the eastern coast of the United States and Canada. It's a strong current of warm water. It influences the climate of the east coast of Florida, actually all the way up to New York and even as far away as Europe. England is about the same distance from the equator as the very cold regions of Canada, but England has a much warmer climate. And this is due to the warm water of the Gulf Stream being transported up there. Here's a short 1 minute review video of that. Okay, so at this point you should be able to answer the do now question. What is the name of the ocean current off the east coast of the United States? And is it classified as a warm or cool ocean current? So the answer here, pretty well highlighted in this first sentence here. So that would be a good thing to include in your answer. At this point, you should be able to complete that do now very quickly. The next part of the assignment today is dealing with global winds. Global wind is a type of wind that is encompassing or encircling the entire globe. Not so long ago, ships could only sail in the direction the wind was blowing, more or less. For centuries, a ship could be made or broken by how hard the wind blew. The trade winds were named because they were a reliable way to get across the ocean. Ships engaged in trade needed these winds to take or leave goods. The trade winds are one of the global wind belts. Global winds are winds that occur in belts that go around the planet. Like local winds, global winds are caused by unequal heating of the atmosphere. Earth is hottest at the equator and gets cooler towards the poles. The difference in heating creates huge convection currents in the troposphere, which is the lower level of the atmosphere we live in. At the equator, for example, warm air rises up to the tropopause, about 8 miles. When it can't rise any higher, it flows north or south. By the time the moving air reaches 30 degrees north or 30 degrees south latitude, it has cooled somewhat. The cool air sinks to the surface, then it flows over the surface back to the equator. Other global winds occur in much the same way. There are 3 enormous convection cells north of the equator and 3 south of the equator. Global winds and the Coriolis effect. Earth is spinning as air moves over its surface. This causes the Coriolis effect. Winds blow on a diagonal over the surface due to the Coriolis effect. From which direction do the northern trade winds blow? Well, without the Coriolis effect, the global winds would blow north to south or south to north. But the Coriolis effect makes them blow northeast to southwest, or the reverse in the northern hemisphere. The winds blow northwest to southeast, or the reverse in the southern hemisphere. The wind belts have names. The trade winds are nearest the equator. The next belt is called the westerlies, and finally the polar easterlies. The names are the same in both hemispheres. Another example is called the jet stream. They're fast-moving air currents high in the troposphere. They are also the result of unequal heating of the atmosphere. Jet streams circle the planet mainly from west to east. The strongest jet streams are the polar jets. Pictured below is the northern polar jet stream. So here's figure 1 of the global wind belts. The Coriolis effect causes the wind to turn to the right or to the left in the southern hemisphere. So on the right in the northern hemisphere, to the left in the southern hemisphere. These are called the westerlies because they're blowing from the west. So western from the west to the east. These are called the easterlies because they're going to the east or northeast. Figure 2 is talking about the jet stream. The jet stream. This jet stream helps planes fly quickly from the west to the east, so planes will travel through that jet stream. But going back from the east to the west, they have to avoid the jet stream so they don't get caught in that high mile-per-hour wind in this direction. When the jet stream dips down low like this, the cold air comes here. If the jet stream goes further higher up towards the North Pole, the warm air travels up in that direction. So what causes winds to blow?
On a greater scale, we find regional winds affecting weather over larger areas. Generally, large land masses, or continents, heat more in the summer than large neighboring areas of water. And in the winter, this land cools more than the nearby water. These temperature shifts create wind patterns. For example, in Asia, we have monsoons, which are steady prevailing seasonal winds. So that in India, winter winds are dry, blowing from the land to the sea. But then, during the warmer months, the monsoon season, warm, moist winds blow from the sea, causing an extended rainy season.
Local and regional winds are the result of area conditions, but global wind patterns produce larger air movements. Such wind patterns are caused by the Earth's rotation and the unequal heating of our planet's surface. Receiving the sun's most direct rays, the equator has the globe's warmest temperatures, while at the planet's opposite ends, the 2 poles receive the most dispersed radiation, registering temperatures usually far below freezing. Because of these constant temperature differences, hot air at the equator rises and moves toward the poles, while the cooler air at the poles sinks and moves toward the equator, thus creating a continuing wind system. The Earth's rotation causes these winds to shift. Think for a moment. Which way does the Earth rotate?
The Earth rotates on its axis from west to east. Because of this, the winds in the northern hemisphere curve to the right, and the winds in the southern hemisphere curve to the left. Scientists call this wind shift the Coriolis effect. To avoid being blown off course to the west in the northern hemisphere, pilots must calculate the Coriolis effect in their navigation. Generally, on continents around the world, prevailing wind patterns are westerly, going from west to east. So in the U.S., it's not unusual for California weather to be headed in a few days for New York and other eastern states. Sometimes this westerly pattern is influenced by colder air from the poles, deflected by the Coriolis effect. Severe weather is likely when this east to west wind flow occurs.
Okay, so at this point you should be able to answer these questions. You have some true, false, some multiple choice, and this will count as your assessment today. Do not forget to hit submit. And when you complete that assignment, you can go on to the exit ticket, which is a review from last week about tsunamis. So the exit ticket, what causes a tsunami? What type of damage did you witness in the video? Explain what type of action you could do to protect yourself and property from a tsunami. If you completed the midterm, this is kind of a repeat from the midterm. Here's a video.
The warning, the sign of sudden, the time moves in reverse. A thunderous roar fills the air, and then it strikes. And when it is over, nothing is left. A tsunami. The word in Japanese means harbor wave. Japan has been hit by many tsunamis in its history as a result of its location. It lies across the edges of 4 tectonic plates, where most earthquakes, the principal cause of tsunamis, are born. When 2 tectonic plates push together, the resulting earthquake sends an enormous burst of energy up through the ocean, displacing enormous quantities of water. A series of waves expands in all directions. In deep water, these waves travel fast, up to 500 miles an hour, but only reach a height of a few feet. A passing ship might not even notice. But as the waves enter shallow waters, friction with the ocean floor lowers the wave's speed and raises their height until at landfall they can engulf a 10-story building. Unlike ordinary waves, a tsunami wave doesn't crest and break. Instead, it advances like a wall of water that crashes over the coastline and everything in its way, reaching even as far as a mile inland. More damage is caused when the wave recedes, dragging everything in it back underwater. And most tsunamis have multiple waves, each arriving anywhere from 10 to 60 minutes after the first strike, just when survivors think the danger is over. The deadliest tsunami ever recorded occurred in December of 2004. An earthquake off the coast of Indonesia triggered a tsunami that surged across the Indian Ocean and reached as far as the coast of Africa. Whole sections of cities were destroyed. More than 200,000 people died. Most had no way of being warned. 5,000 miles away, the Pacific Tsunami Warning Center in Honolulu is on call 24 hours a day to prevent a similar tragedy from happening in the United States. Scientists monitor tremors and quakes from around the globe. If a quake big enough to cause a tsunami occurs, it is their job to alert the coastlines in the tsunami's path. The advice is simple. Move to higher ground, wait for news that the tsunami has passed, and be ready to deal with the ruins left in its wake.
Okay, so this will be the exit ticket. So you should know what causes a tsunami, what type of damage did you witness in the video, just short explanation, and what type of action could you do to protect yourself and property from a tsunami. The main reason is protect yourself. What would you do if a tsunami warning system was alerted, and you know a tsunami is coming, you live near the ocean, what are you going to do?